Hi, and welcome to this video on using the STM32CubeIDE IDE. I have it here on the desktop. I'll go ahead and double click on it, and we're going to do essentially the hello world for FreeRTOS. Show how we can do that with this development environment. I'm Norman McIntyre. Let's get started. So it starts up in this where it's going to put my workspace, and I'll say launch. And I'll begin with a brand new project. So file, new, and when I say file, new, the project I'm going to choose is an STM32 project. It's initializing the STM32 target selector. That is, it's getting a list of all the target microcontroller units and also the different boards that I can use. Notice here is the microcontroller unit selection, and they're all down here, and also we have the board selector. So I'll go to the board selector, and here I'll put B dash, and I see the board that we're using excuse me, listed right here. In fact, it's this board that's we've been using in our course. This is the model number here by looking at the large picture. This B-L475E and so forth. So that's what I'm filtering as. So I've got the board selected, then I'll come here and click on next. Once I click on next, it wants to know the project name. Let's call this hello, how about FreeRTOS, and we'll do finish. And then initialize all the peripherals with their default mode. The idea here is that since this board is already built, it knows what the pins are, and we're going to say, yep, go ahead and initialize it to those defaults. And yep, associate this project with the STM32CubeMX. I've noticed sometimes this happens very quickly, and other times there will be a delay, but it's always just a slight delay. And in this case, we see we've got our default project here. This is shows us the pins that we've got selected. I want to show right here, notice this pin says LED 2. And this is the green LED that is on our board. And I want you to notice it's PB14. So port B, pin 14. And we'll use that as part of this Hello World demonstration. What I'd like to do is flash that LED on and off, and I'll use the FreeRTOS delay code to be able to do that. So here's what I'd like to do. I'm going to go here where it says middleware, and under middleware, notice one of the options is FreeRTOS. So I can choose FreeRTOS, and I want you to notice that by default FreeRTOS is disabled. Okay, so it is disabled, but I can click on this and say we can enable it, and notice we've got the option of enabling it for version 1 or for version 2. We want to use version 1. In this case, I'll use version 1, and then it gives me all the different options it's got here, and there are a ton of options. But remember, we're wanting to do just the plain old hello world for FreeRTOS, so we won't worry about modifying any of those options. At this point, if we save this project, if I click on save, it's at this point it's going to say, well, do you want to generate the code that is part of what you've selected here? And I'm going to say yes, I want you to generate the code, and we know it's going to generate whatever code we need. Notice the message here. It says when FreeRTOS is used, it's strongly recommended to use a HAL time-based source other than SysTick. The HAL time-based source can be changed from the pinout tab under Sys. So since it's warning us about that, and it says, do you want to generate the code, we'll say no. And then remember it said if you go to the pinout tab under sys. So what I'll do is here is the pinout tab right here. Right, we've got the system view and the pinout view. And over here, if I come where it says system core and I expand my system core, I want you to notice we have something called sys. And we see right now that none of these have been turned on, right? Right here where it says sys, the time-based source is systic. This is what it was warning us about. It was saying we recommend you don't use systic, so I'll use time1. Right? So instead of using sys, we're saying for our time base we'll use time1. Now there's a lot more to say about all of this, but remember our goal here is to do the Hello World version of this. So I'll click on Save This. Do you want to generate code? Sure, I want you to generate the code. And notice now it's generating the code, but we're not getting that error message that we got previously. Now all of this is called the perspective, the MX Cube or Cube MX perspective. That's what this guy is here. That's this perspective. They call it the device configuration tool. But also if I click here, that puts me in the C development tool. So notice when I put the C development tool, this perspective is a little bit different, including it shows me my build analyzer. So what I'll do is come over here to where it says source code, and I'm going to double click on main.c, and under main.c what I will do is come down to where we have our while loop. So I'll come down here to where we have the while loop, and when I look at this, when we see that the OS start kernel, it says we should never even get to the while loop because right here is starting the scheduler. So what that means, if we want to put some code that will do something for us, we probably want to put it inside one of these threads that we have here. So notice they create a default thread for us and they start that thread up. In fact, if I look over here, this is how I basically can scan my different functions. If I scroll down, I want you to notice there's something called Start Default Task. So I'll double click on Start Default Task, and here we are. And we see here we've got this user code and we've got our user delay of just 1. Well, I'm going to make that a delay of 1,000. So this is going to be OS delay of that many milliseconds. And then I believe there's two things I want to do. I want to turn on the LED. Well, one thing I want to do is turn on the LED. So I'll say HAL GPIO toggle. I press Control spacebar and it says I can toggle a pin. Remember, the pin I want to toggle is GPIO, and I can press Control B or Control spacebar, and notice I've got GPIO B, so it's that port. And then the pin, I can say GPIO underscore pin, Control spacebar, and we want pin 14. So that will take care of doing that, and of course it'll then delay. And if I run this, I should be able to see my the LED flashing. So let me come here, right here where it has the bug, and I'll click on the bug, and it says save and launch. Yep, save my changes to main. Down here we see it doing the compiling. We see the analysis of how much memory we're taking. It wants to switch to the debug perspective. I'll say sure, switch over to that. We hit our first breakpoint. At this point I can either step, one step at a time, or in this case you just may want to say resume. And when you say resume, in my case I had set a breakpoint here on the toggle just to show we get to this to this task, and now I will do a breakpoint, and we have the delay. Of course, it delays a second, and then we toggle again. And in fact, at this point, I could say, well, I'm going to go ahead and remove my breakpoint and just do a resume to run full speed. Let me go ahead and remove this, and now let's resume. Cool. Now it's running our code, and if you were looking at your board, you'd be seeing the LED flash on and off. And of course, we're using the HAL GPIO toggle, and we're also using our API that says HAL OS delay, which is one of the FreeRTOS delay calls. I'm Norman McIntyre. Thanks as always for watching.